Hi, this is the instructor. Let me turn on my face just few seconds. Today's topic, BIM design representation. Okay, so far we have walked through some building information modeling tool, representative tool, market share. The top priority, the major market share tool, Autodesk Revit. Okay, let me turn off my face first. Revit looks like very powerful BIM tool, BIM authoring tool, and we found some good render feature, even if it's slow, but anyway, it can render very precisely, and we experienced a very powerful object-based modeling approach in the perspective of architecture and design, not just focusing on faces, surfaces, point lines, or some kind of subgeometric components. Instead, we can keep focusing on real core design elements such as wall objects, window objects, slab and structural joints, curtain system, and amount of the furniture or some kind of design elements we need for making design. So let's take a look. Geometric modeling versus BIM. I 100% sure that you already know what's the differences between them. And take a look. 3D Max. Currently we are taking some render aspects of 3D Max from last week. For example, sun setting and simple mental array render, and today is one of the lab exercises will guide you to create 3D Max specific photometric lighting system so that you can create much better render output in the perspective of photorealistic render. Okay, and I know most of you students are using SketchUp. It's a kind of de facto standard tool in specifically interior coordination, interior design, interior decoration domain. There are amount of interior design representation examples using SketchUp. That's fine. SketchUp is very representative, easy to use, surface-based 3D tool. But now you know the power of Revit and its advantages when you are using Revit or similar BIM tools. Design visualization matters always. You know that. Why we design? Of course, we are going to construct and build in real world, real component, real world objects. But for one real building, how many design visualizations we need? I'm not sure. It's uncountable, but anyway, several hundreds, thousands of visualization and review process going to be needed anyway. Because of that reason, still geometric modeling and design visualization, simply say, quick visualization. Oh my god, it's okay. I'm sorry. Okay. Specifically, quick visualization. Another one, early visualization. Quick visualization means you can simply visualize your idea or your shapes, your design, things, whatever. And early visualization means even if your design is totally premature means it's not fixed. It's not your specific idea, but you got a concept and you have an idea to implement that idea. So in that case, you have to quickly visualize your idea in early stage of design. That's why I'm saying quick and early visualization matters and very important. For that reason, sometimes beginning with Revit for your new building design or new interior architectural planning or some remodel project, whatever it is, using BIM for early phase design, sometimes it's too much heavy loaded and sometimes it's not possible. Okay, so in actual field early phase design done by SketchUp, AutoCAD, Rhino, it's very common. Okay, starting with those geometric tools. In the meantime, sometime in certain point, early phase of project, middle phase of project, final stage of project, they transform their design environment using BIM or Revit. That's so-called often used approach nowadays in professional domain and so on. So today's my topic is you're supposed to use BIM or you need to use SketchUp because you are good at SketchUp. You can use Rhino, whatever you want, just use it. Only that tool gonna provide you the final solution, something like that. That's not my intention, okay? As always, I always put an emphasis on interoperability, some kind of interoperable approach to design development. That means, simply say, as many as applications you have to use for better design or efficient time frame or for saving money or for constructible, realizable model or something, okay? There are many reasons to use that kind of interoperability things while you are designing, okay? Broadening your horizon so that you can create much better design, technically better design, visually better design, and so on. But today's topic is visualization. So 3D modeling in the perspective of design visualization, take a look. This is 3D Max generated render scene. You know what? You need only 5 minutes, but actually not 5 minutes, just 1 minute is okay. Last week you experienced this one, and today's one of the lab exercises going to be similar to this one. This one has 1, 2, 3, 4 lights above, photometric lights, sphere shaped. But take a look, why it's black? Because it's empty, black sky. There's nothing in this universe, in this world. There are nothing except plain teapot and 3 metal looking balls. That's it. But take a look, this one is looking very photorealistic. You can make this one in 1 minute or at least 5 minutes. What if you need to create this one, this kind of shape using Revit? Frankly, technically say, it's not that easy. It's not easy to create similar objects in Revit because there are no ball objects or teapot objects. Instead, you can import geometry or you can download some Revit components and so on. But my point is, by using Revit, this kind of visualization, very, very inefficient. That's not good, okay? You already know that. That's my point. So let me quickly show you some conventional geometric design scenario. 3D Max scenario is same to geometric design scenario. You used to use this scenario in your design studio or some other type of project work and so on. At first, Define universe of discourse. Define your word. For example, you are in charge of making a housing unit for a house, or a co-housing building, apartment, or you are in charge of some commercial building, office building, and so on. That kind of thing is sort of one type of universal discourse definition. Determine what's in your mind and roughly sketch and define your universe. Create universe. Create universe means starting modeling, geometric modeling. Environment model first. The same as we had to make some OSM based street map, or some Google Earth based model, or Rabbit's Math, or some AutoCAD line drawing based your site drawing or something. This is environmental modeling. And your elements, design components modeling. Planes, walls, sky, outside view, modify again and again. 2D sketch, 3D modeling, import geometry, modify again and again. It's a loop. It's an iteration. Sometimes never ending. All nights. Anyway, and then you need to visualize rendering. So this is sort of time consuming. Time consuming, in other words, tedious. I forgot the spell. Anyway, tedious. Tedious means very boring task, right? How about render? Actually, rendering time in the perspective of computer CPU or GPU, it's not your time, right? It's computer's time, hardware's time. So let's take it aside. It actually doesn't take much time. Instead, you need to know a lot of technical things. For example, materials, mappings, bump map, reflection, diffuse. Amount of mapping techniques available. You don't need to be stuck or stunning for that kind of unnecessary technical things, but if you are in charge of rendering, this is inevitable. Very complicated, but anyway, you need to know precisely in detailed way. How about lights? Photometric lights, one of your subject for this week's lab exercise, but anyway, there are many different type of lights. Omni lights, spotlight, free light, target lights. Some technical tweaks, very tricky things you have to take account. How about camera? You need to know some mechanism of physical camera, lens, focal distance and focus, and exposure control, brightness. There are amount of things, huge list you have to know for handling this one. And then you can test render again and again. So what's this? Iteration. You have to see your result. Probably you don't like it. Go back to modeling, or go back to texture mapping, go back to lighting, go back to camera control again and again. That's why I put this term iteration. Also, you need to retouch using Photoshop or something, right? Or if you want to make animation, movies, this kind of iterative and very time-consuming tasks should be done. Until when? Until the final result you like, you get, okay? And the next slide shows you again CAD history. I introduced you this one at the beginning of this semester. You remember that? Of course, yes. Anyway, last week we have walked through Dynamo, and I told you Dynamo or computer code based design modeling approach is sort of the most advanced. In other words, sort of cutting edge computer modeling for design. So this approach is one of the parametric modeling. What are some lightweight parametric modeling? For example, dimension based. That's kind of minimal parametric modeling, maybe. You can control height, thickness, width, and so on. And you know that constraint-based modeling, also parametric modeling. For example, without wall object, you cannot place window or door object, simply because constraints made by original modeler. It's similar to rule-based design, rule-based modeling. Anyway, parametric modeling is mathematical equation-based approach for geometry making, shape making. In other words, simply design, right? So this BIM approach, the most cutting-edge approach, includes parametric modeling, solid modeling, surface modeling, and very conventional 2D modeling. All components are subset of building information modeling approach. That is why one of the important part of BIM is parametric modeling. That's what I mentioned in this class. So from the solid modeling, we have walked through this part so far in this class, in this semester. I assume that this part, sort of 2D CAD and surface-based representatively SketchUp approach, I assume that you already know this part. Even if you don't know about this one, still we need this one, because the most advantages of this kind of CAD drawing approach or surface-based 3D modeling is, I told you today, quick visualization and early phase of design, early design. If you have very roughly made idea, what's the good tool? It's not going to be Revit. You know Revit is heavyweight and you have to determine objects. But what if you have an idea, very gorgeous, totally new shaped building skin or interior wall surface? You don't know what is that. It could be wall object, it could be some kind of component, it could be some kind of curtain system or truss system, or something couldn't be existing in real world. You are in charge of creating very creative new objects sometimes. But Revit determines the objects existing in real world. That's why you still need this kind of approach. And that explains why our lab exercises offer you some kind of 3D Max modeling or so far just render visualization purpose. So here is my reason again why we still need this one for quick visualization and early phase of design visualization purpose. So even in this kind of advances, we still need this legacy approach. Sorry, it's not that easy to write text using this tablet. Anyway, I'm 100% sure that you fully understand this process, CAD history now, because you have learned and you know what's parameters, what are parametric modeling, and how Dynamo or this kind of parametric modeling approach is very, very powerful and useful for specifically for real world components like buildings. And that's biggest part of building information modeling approach. So surface model, solid model, non-solid examples, and why we need a solid model? This is an invalid example, and this is ambiguous because this one could be anything. Usually we assume that, okay, this one is this one, but you know what? This one could be this one in this kind of wireframe view. In other words, it's ambiguous object definition, ambiguous design definition. That is why we need the solid part and void part. You know how Revit deals with this kind of solid model. You know void object, you know void object, you know solid object, and you can combine them in order to make this kind of whole panel. You remember this one last week lab exercise, right? We make this kind of void object and we made this one solid object. Anyway, this is kind of solid based geometric operation thing. So geometric modeling approach, by using this one, you have watched this one in flip learning video. Let me quickly move it. Real world building and Revit based representation using BIM, right? AutoCAD 3D drawing, SketchUp 3D model. What if you use this kind of tools? What if you used SketchUp for making this building? Now you can say this one is really time consuming, and I'm not sure. We don't need to say it's a kind of stupid approach, but sometimes you can feel like that. We have object-based building information modeling approach. Why we use this kind of thing? In this project, Revit is a good tool, but I told you before, if you in charge of early phase design visualization, quick visualization using kind of surface-based thing, photorealistic render, or kind of concept visualization, in that sense, Revit is heavyweight. You don't need it. What you need is SketchUp, 3D Max, Rhino, whatever. Surface-based 3D, okay? That's why we still need those tools. That's what I'm saying. But as we know, this is 3D Max modeling interface. Unnecessary complication. Why we need to take a look at this kind of vertices should be joined or enclosed or something. Without this kind of problem solving, it couldn't be make 3D. I believe you should know this kind of thing is not necessity. It's an unnecessary task. We have to keep focusing on developing our design in the perspective of designers' brain, designers' great ideas. But in reality, we stick to this kind of stupid problems. Those two yellow points supposed to be welded and joined. Why? If not 3D Max SketchUp, they couldn't make some appropriate 3D shape. That's ridiculous. That's my point, okay? Anyway, in this way, we can create this one. This is 3D Max, okay? 3D Max. Extrude, cut, and this is, you remember that, how Revit and Family Editor can create this kind of shape, controllable. But this is just geometry. It's not controllable. 3D Max doesn't understand this part is mullion, in other words, frame, and this part is glazing. Glazing means glass, okay? Translucent object. 3D Max doesn't understand what are they. It only understands points, lines, faces, polygons, and so on. That is why we use, to create this one, we use edit poly, inset, bevel, detach, and so on. This approach is sort of legacy approach, and the manner, the way we used to use, and probably some of you still wanted to use this approach, but I like to encourage you to shift your perspective from this approach to really intelligent and smart advanced modeling approach such as Dynamo or some parametric modeling, family editor, or at least Revit-based modeling. Anyway, 3D Max representation, visualization, importing CAD file, exporting, extruding, and making this one. All these are 3D Max example. 3D Max. Sometimes I told you 3D Max, AutoCAD, SketchUp, very nice, very good. But what if you import Revit generated objects into 3D Max and place today's lab exercise? You will learn how to control this kind of 3D Max photometric lighting system. Anyway, modeled from Revit and visualized in 3D Max. This is that example. You know that this kind of Revit objects can be visualized quickly in Revit, but sometimes it's not that visible, not that sharp, clear image you want. That is why I recommend you maximize your utility, maximize the output quality using both Revit BIM approach and this kind of geometry conventional legacy approach. Okay, take a look. This kind of visualization, some kind of Photoshop edited. Take a look. This is really good early phase design and quick visualization. But originally modeled Revit and imported into 3D Max mental ray. This is mental ray render. Autodesk material assigned on the floor, ceiling, objects, not that colorful because I intentionally assign all the same white, light gray colored material, but they are reflective because it's Arc and Design good material. Arc and Design material is really good material in Autodesk material. You can find out this material in 3D Max mental ray material editor. Anyway, this is really good early phase design, quick visualization, concept visualization. So that is why still 3D Max, SketchUp, Re-ray, mental ray, very critical for your not realization of building, for your realization of your design studio, frankly say, okay? So take a look. This is Revit. Revit also offers amount of good visualization, more than photometric render. We know how to render this one, render scene, right? But even without render, architecturally, you can make this kind of visualization. Take a look this screen. How's it look like? I believe this is really good architectural or design perspective representation. Also, you can easily create this kind of shadow, right? Shadow generation. How about this one? Click graphic display options. On the shadows, if you click cast shadow, that's just shadow, okay? How about this one? Show ambient shadows. Click this and click OK. So take a look. If you zoom in or zoom out, this kind of ambient visualization a little bit changed, but this is much better than nothing. Let me show you. If I turn on section box, here's section box, and if I control this section box here, let's take a look. Even the indoor spaces, this is section profile. This 3D section also visualized by this kind of ambient shadow. Some architectural representation or even in floor plan view, or this kind of top view. Okay, this is not good. I am gonna change this one to bottom somewhere here. Okay, how about this? Let me click top view. I just applied only ambient shadow, but it looks good. How about actual shadow with ambient shadows? Even if this is section view, anyway, this one looks like architectural drawing. Very design specialized graphical representation. Even though this one doesn't have any colorful things, any color, only this one has black and gray, grayscale representation. This kind of visualization sometimes much better than photorealistic render. Sometimes. That's my point, okay? Actually, today's one of the lab exercise is getting sheet, something like this. Take a look, this sheet. Very professionally looking dimension marked floor plans and elevations. If you change this one, this elevation with shadow casting or some ambience, this sheet also can be updated. But sometimes this kind of line stroke generation, line stroke visualization you need, and very useful for architectural representation, professional representation, simply because this is so-called industry standard. Take a look this frame. I actually added my lab image here and some text regarding this document. But anyway, if you export this one into PDF format, this is PDF file format. You can zoom in, zoom out. This is vector format because it's in PDF. Take a look. This one looks like AutoCAD made floor plan, but this is not AutoCAD made. This is Revit's auto-generated elevation, section, and floor plans. Okay. So this kind of professional looking image sheet also can be creatable from Revit. So this is one of the lab exercises today. Hopefully you can walk through this lab exercise without any problem, and I believe you will take a look a little bit more about Revit BIM approach for better design representation. Hopefully, okay? Thank you for today's lecture, listening my lecture.